AI train the model with a complete data set. Okay, so this is our data set, correct? Here, this one. So it has around 169 files, correct? With all our CSV file and all has same columns and similar kind of data is there for the CI/CD attacks. And if you observe the data size of this particular or files are 13.8 around 758 GB. So it's almost 13.8 GB, almost 14 GB. Okay, so if you try to train this particular model for this on particular this data set, so your local system won't be able to do it. Okay, if you have more than 32 GB or 64 GB RAM, then you will be able to do it. Okay, so you have to use Kaggle. Okay, even Colab is also not able to train this particular model algorithm, because Colab is also having only 12 GB of RAM. Okay, only Kaggle having 28 GB of RAM, okay, where they provide around 25 or 24 GB for openly and remaining they keep for internal operation, okay. So we have used Colab algorithm, Colab, Kaggle, okay, not Colab, we have used Kaggle notebook. You can also create your notebook, okay. So this is the data set for separate files, okay. There's a one more data set available on Kaggle which has merged data set, okay. So this is basically combined files of all these files, okay. So we no need to do the combining of that file because that also take the RAM and space. So we don't have any space, okay. So we are using this data set, okay. Both are same, okay. They don't have any difference. Here you can also see it is memory size is also same. Here also the memory size is same, okay. And if you see, if you count, do the calculation, the count is also same, okay. So this and columns and everything is same, okay. Data set is almost same, okay. Almost not, it's same only, okay. So we have used the data set, okay. And the strategy which we have followed, okay, I have created a particular flow chart ki what strategy I have followed to get it trained, okay, with less memories, GB RAM, and to train this particular 13 or 14 GB model, okay. So what we have done, first we have done the feature detection, okay. If you see in the code, I have given you three different folder, okay. There's one is feature selection, there is a multi classification and binary classification. First what we have done, first we have done feature selection, okay. First we have identified top 10 column features of particular data set. As you said, you just want 10 to 5 columns features, okay. So 5 we can't take because algorithm can give 99% accuracy, because it's already a very clean data, okay. So that's why we have considered top 10 features, okay. So with this notebook we have identified top 10 features, okay. And to speed up the process, here we have used GPU, okay. We have used Kaggle GPU, okay, to get it trained and to get it in less time, okay. So here what we have done, here is the complete code written, okay. So and here is also complete output of the code, okay. So what we have done, first we have identified key whether GPS supported or not, okay. And we have used XGBoost algorithm to get the features, okay. Because other algorithm won't be able to calculate that in the particular memory size with the data set. Only XGBoost algorithm can able to do that, okay. And what we have done, as we have only 28 GB RAM, so we have added a limitation ki it should not go beyond 24 GB, otherwise system will get crash, okay. And then we have performed some data analysis, and what we have done, we have processed 5 million records, okay. So the strategy which we have followed, see, around uh, there was around 34 labels are there, right? 34 attacks, types of attacks are there, okay. So there are 16 classes which are belongs to which having very low number of records in the data set, okay. And 18 classes having very high number of classes, like 10 or 20 lakhs records are there for the particular 80 classes, okay. So what we have done, first we have loaded these 60 classes, okay. What we have done, whatever 60 classes are there, if you go up, so there are 60 label classes are there. Yeah, these are the 60 label classes which has very limited rows, like 1 lakh, 10,000, 20,000. So what we have done, we have loaded this 16 classes first, okay, and then we have loaded this high frequency classes, okay. We have splitted the particular number of classes, and we have calculated ki how many rows are remaining out of 5. First we have loaded 16 classes with all rows, okay, then whatever, see, we have targeted only 5 million record to load, okay. So first we loaded 16 classes records, and whatever number will gets remains out of 5 lakhs, okay. So if I tell you, so for 16 classes which are having very less records, if you go to this output, see, there was total this number of records. These are the total classes, okay, and these are the these are the number of records for low classes, around 6 lakh only. Remaining budget we had 43 lakhs. So for remaining 18 classes we have loaded this 43 lakhs data, okay. So this way we achieved this 5 lakhs of records, because our system capability was only 5 to process 5 lakh records only, okay. Beyond that it will get crash, okay. So then we have used chunk technique. We have divided the data into different chunks, okay, and then we have loaded the 5 lakhs 50 lakhs record accordingly, okay. And after that we have run this model particular XGBoost algorithm with the GPU, okay, and it got trained, and after training it has identified top 10 features, and we have exported that top 10 features data into separate CSV file, so that we can compress data, because remaining columns we don't need now. We only need top 10 features to get model trained. So that's why we have escaped or remaining classes or remaining columns, so that data set size should get less, okay. And accordingly we have exported the data, and finally we got 450, around 450 half of GB data, okay, because algorithm data set has almost 50 columns was there, okay. So almost it got reduced, okay, because we only considered 10 columns, because we wanted to calculate top 10 features only. I have also exported top 5 features. If you want to train on top 5, so you can also do the same, okay. So yeah, this way we have exported and compressed the data, okay, by analyzing the complete data, okay. So we have used 50 million records to train the algorithm, okay. This is the complete flow chart ki how we have loaded the data, because this is something kind of novelty which you can add in your thesis or paper, which we have introduced, okay. And this is something which you won't be able to find it on internet, this technique, okay, because that is something which I have explored and done some research and identified this thing, okay. So that this way we have done this dataset feature extraction, okay. And then we have trained our algorithm, okay. For the algorithm binary classification and multi classification, the code are same which we used previously, because there only we have done all the process. Only thing, from there I have removed outliers, feature detection, whatever you have suggested ki remove it, okay, I have removed all those things, feature detection, feature selection, okay, and to enhance the feature engineering, okay. So all those things I have removed, okay. Only use top 10 features columns which we have generated, okay. And here you can see now we are loading the dataset, top 10 classes dataset, okay. Here if you replace with top 5, then algorithm will automatically train on top 5, okay. You just need to upload this particular notebook on Kaggle, and you even don't need to upload the dataset, okay. I have uploaded on drive, okay. So it will automatically download the dataset from there, okay. And there we are loading the classes, okay, libraries, loading the dataset, and doing some analysis like plotting graphs, okay, and identifying how many label has been divided internally, okay, and doing label encoding, okay, and then dividing data into x and y, splitting the data into training and testing, okay. And then we have written a complete common script, so that every algorithm we can just pass the algorithm object, so algorithm will automatically calculate everything, okay, all graphs and everything, like doing basic setup, creating ROC, uh, confusion matrix for the testing data, okay, and training data. These all are key internal functions, and we have optimized that function or created accordingly, okay. Create a performance dashboard, whatever graphs are coming, and whatever uh, comparison as doing all these things are doing from here only, creating ROC curve, okay, calculating performance summary, doing overall calculation from all metrics, okay, and identifying key which are the best, okay, based on overall score, okay, and then creating comparison dashboard where you are having a dashboard proper graph by comparing all algorithm accuracy and everything, okay, and this is the main code evaluation model where is the where we are passing the algorithm, and accordingly it will internally calling the sub methods, okay, calculating memory size, okay, how much time it required, or everything is doing here, okay, training time, testing time. If you see line by line code, it's very easy code, okay, you can get it, okay, and then whatever result we are getting, we are storing in a map so that we can compare it, okay, and then we are creating the class wise analysis, okay, key every class, what is the accuracy of every class, and generating the radar chart as you requested, okay, and this is the for compare model key. From here we are comparing the all algorithms, we are just passing the result, whatever result we have stored, we are passing it here and comparing it, okay, and this is the performance ranking, okay. So this way we have done overall. Then we are passing random forest. The algorithm part is same because I have used every machine learning algorithm and top three algorithm which I have identified, that I have included. Okay, if you try to train any algorithm, any other algorithm, you will get very less accuracy, around 50, 60, 70. Okay, but this top three algorithm is performing very well, around giving more than 90% accuracy. Okay, so keep, if you want to explore, you can also just create the copy of this algorithm and just replace your algorithm and just pass it, okay, it will get trained, okay, it's very easy, and it will automatically generate everything, okay, you just have to run a block wise, okay, and in the last we have done the voting ensemble model, okay, there also we have got good accuracy, okay, so everything was overall good, okay, and I have generated the zip file and all plots and graphs are there, okay, same way we have done for binary classification. Just for binary we have just removed, we have just combined the all attack classes in tags, and remaining we have keep as a normal, okay, that's only change we have done, and remaining code are same just like multi classification, okay, and here also algorithm part, training, testing part, everything is same, just it's binary classification, okay, so this way we have done overall system.
Thank you friends for watching my video. If you are new then subscribe channel and share with your friend. Thank you.